That just summarizes the different types. Well, where do these radioactive elements come from? That's a good question, huh? Why do we have them? Well, there's three reasons really. One, some of these things were here basically from almost right after the beginning of time. First there were neutrons and then there formed all these other elements, right? When all those other elements formed, some of those elements and isotopes were radioactive, i.e. uranium and several other ones. So some of them are what we call primordial. They've been here since the beginning of time. Second one is, well, when some of these radioactive isotopes decay, they make new radioactive elements. So when uranium decays into thorium, thorium is still radioactive, okay? The last case is transmutation. Transmutation is a word that comes from alchemy because remember, alchemists were trying to turn lead into gold, right? Well, in this case, we really can change what we have as an element. If we take a helium nucleus and bombard it into a boron atom, look at what happens. We get a new nucleus that's a nitrogen atom. Basically, you take two atoms and smash them together, you make a new element. That's what we do in controlled in a superconducting supercollider. This happens all the time up in the upper atmosphere. Why in the upper atmosphere? Because there's more energy there from the sun. And the sun provides the energy to make these new elements like this, okay? It doesn't happen here because there's not enough energy. All that energy is being blocked by the atmosphere above us, okay? So that's the third source of elements. Don't worry about this. So how do you measure radioactivity? That's a good question, huh? Well, we talked earlier about some people wearing little dosage badges, right? They're actually measuring radioactivity. This guy has in his hand a Geiger counter. And I always find this to be humorous because Geiger counters are inherently not very sensitive, okay? If he measures radioactivity, the concentration is really high, okay? Like so high he should be scared and he should run probably, okay? Some rock formations have high radioactivity naturally from primordial elements. Most do not. And this is a better picture of a Geiger counter and how it works. Here's the Geiger counter. This is the little piece that you would hold. It looks just like a microphone. And when you hold it up to something that's radioactive, it causes a reaction inside the microphone and the thing clicks, right? You probably all seen them on TV and movies and stuff, right? They're not very sensitive. My biggest issue with these guys that do nuclear chemistry is look at the units that they use up here for measuring radioactivity. There are 4 sets of units up here. Curies, becquerels, rads, and grays. Then there's also rems and some other stuff too. They can't agree on units for some reason. They each have their own use and different people use different ones. It gets confusing, so I don't even want to try to do dimensional analysis with these guys. How's that? Just suffice to know, there's lots of units. The last unit on here is REMS, radiation equivalents in humans. It measures a biological effect. Sufficient to know that those little dosimeters are normally calibrated in REMS, okay? Because they're trying to figure out if it's going to damage your body tissue or not. So how do you get exposed to radiation? Well, this building has concrete blocks, right? Let's just say this. The people that sit next to the wall are exposed to more radiation than the people that sit in the middle of the room. Did you know that? Because when they make concrete to make that block, the dirt that they use to make the concrete is high in a couple of different radioactive elements, okay? Now, it's not enough that it's going to hurt you, okay? So, I mean, if you want to sit in the middle next time, you can, but it's not. I mean, you've been sitting there all semester, you ain't got sick, right? So you're going to be okay, all right? But it is slightly higher right next to the block than it is over here, okay? Where else else do you get exposed to radioisotopes? Medical and dental procedures when you have x-rays done, or some other procedures we'll talk about. Why air travel? Flying in an airplane. Because what I talked about earlier, that transmutation process makes radioactive isotopes in the upper atmosphere. If you're in an airplane, you're going to be exposed to that, right? Smoking cigarettes increases your exposure to radiation as cosmic rays. And let's talk about radon gas. Anybody know anything about radon gas? Anybody ever bought a house and had it tested for radon gas? No? Let's see. See, I've been around longer than most of you, huh? Back in the 70s and 80s, when the price of oil started really going up, it got expensive to heat and cool your house, okay? And so people figured out, well, if we build these houses that are really super insulated and the windows and doors fit really and it doesn't exchange any air with the outside, then that'll be better because we don't have to heat and cool so much, right? It's cheaper in the long run. But what happened? People started getting sick, and they couldn't figure out why. Until somebody finally discovered that these houses that were super tight were high in radon gas. Radon is a naturally occurring radioactive gas. And they figured out in certain parts of the country, when you build a house like this, if there's a crack in the foundation, the radon can work its way up into the house, and the gas will be in higher concentrations. You breathe it in, it might radioactively decay while it's in your lungs, and then it can cause lung cancer. So in certain places in the country, people are getting really high cases of lung cancer. And it took somebody to put 2 and 2 together to figure out this was why. So in a lot of places, if you buy a new house these days, you have to have it tested for radon. It's real easy to have it tested. You go to Lowe's, you buy a little canister, you put it in your house for like a week, and then you send it off, and then they send you the results. It's simple.
I missed what you said about where the radon came from.
It comes from naturally occurring different minerals in the ground. So it's high in certain places in the country, and other places it's not a big deal. But what happens is it's a gas. The other radioactive isotopes in the ground decay and make radon gas, and in the gas, gases rise, right? So it works its way up into the house through a crack in the foundation, and then it stays in the house because you're not exchanging the air with the outside. So now these houses, they have air exchangers to prevent this, right? So if you live in an old house that's drafty, you don't have to worry about it. Okay? Or if you keep your windows open all the time, you don't have to worry about it. But if you live in a super insulated, really airtight house, you have to have a way to exchange the air in the house, or else radon gas can actually get to high enough concentrations to potentially cause health issues, like lung cancer. Okay? So, and you see that on here, it's one of the big numbers on here, but it varies widely depending on where you live and the type of house you live in. See, and that's why I pointed out concrete earlier. See, if you're sitting next to the concrete block, see right here. Concrete's 50, ground's 20, right? So if you're sitting right next to the wall, you're exposed to more than you would be sitting out in the middle of the room. It's not a lot, okay? So, how much is damaging? This is a term that you'll hear about lots of different toxins and stuff. It's called LD50. LD50 is the amount of radiation or any other toxin that would kill 50% of the population. So if you take 100 rats and you expose them to a certain toxin or radiation and 50% of them die, well then that's the LD50. Okay? Somebody in the other class said, well, how do they figure out the LD50 for humans? And it must be calculated, I think it comes from after dropping the bombs in World War II. You can figure out how far people were away from the bomb drop, and you can calculate how much radiation they were exposed to, and you can figure out how much it took to kill 50% of the people. Okay. Now I look at this and I see a couple of things on here. Note that it takes less radiation to kill dogs than it does humans. Now, this is based on per body mass. Okay, humans are bigger than dogs in general, but still, humans takes, right? It takes less to kill a dog than it does a human. That's kind of interesting, I think. Look at insects. It takes a whole lot of radiation to kill insects. That's why people talk about, well, cockroaches are going to rule the world, right? Man, them suckers are hard to kill, aren't they?
Is that because they have the exoskeleton?
Part of it's because they have an exoskeleton. Part of it's because their neurological system and their reproductive system is very simple. Yeah. But bacteria are easier to kill than insects. And that probably has to do with an exoskeleton. Because bacteria don't have that, so they die pretty quickly. But look at rats, humans, and dogs. So insects are going to have bacteria to eat probably. Everything else going to be dead. Lovely, huh? See, you guys, most of y'all grew up in a time where there's not really a threat of nuclear war. When I was a kid, growing up down in Hope, actually I grew up most of my life in Cumberland County, Fayetteville. When we came back from Germany in 1973, my dad was in the military, we came back from Germany, we used to have drills, you know, like you guys had tornado drills in school when you were younger? We used to have drills for nuclear war.
Getting under the tables.
Getting under the tables is totally useless, right? But yeah, we used to get under the tables and stuff. People used to build bomb shelters in their backyards, okay? Because of this threat of radiation from a nuclear war. It's not as big a threat anymore. It still exists, right? China and some other countries have nuclear bombs that if they decide to act stupid, they could use them, right? The threat isn't. Back then, people lived daily worried about this, concerned about it.